Windows Firewall. In this nugget, we take a look at Windows Firewall, which is a great way to prevent intrusion in your systems. We'll take a look, first of all, at just an overall firewall's functional overview, what the purpose of a firewall is, how it generally works in most networks. It doesn't have to be just a Windows firewall, but any firewall. Then we'll take a look at some of the firewall features that are pertinent to Windows Vista / Windows 7. I kind of use both of them because they're very similar. We'll take a look also at the firewall interfaces. I mean, how do you actually work with the firewall? There's actually 5 or 6 different interfaces to view or access firewall settings. We'll take a look at Windows Firewall with Advanced Security, or WFAES, and we'll take a look at how to actually create some rules using this. That's where most of the demo comes from. And we'll take a look at applying rules also with a group policy object. You'll see that the interface is very similar to WFAES and fairly easy to work with, but applies on a broad scope. First of all, let's take a look here at a firewall and what it's designed to do. Of course, out there on the internet, you have folks out here that are very threatening looking stick people with spiky red hair. And they're trying to get into your systems and either take control, get your banking information, get company information, or just vandalize them. They can also use these to become bots, for example, so that they can combine all their power together to attack some other computers. So there's a lot of different creative hacking methods that can be used to try to access these machines. One of the most common ways of trying to get to them is by using TCP/IP ports, open ports. And what they'll do is they'll find an open port that's on this computer. Let's just say that somehow or another port 80 got left open on this computer and we didn't have a firewall. Well, then they would be able to get in through port 80 and potentially exploit and eventually take over entirely this computer. I mean, there are exploits where they could actually take it over, including using the mouse, using the keyboard, opening up your CD-ROM. I mean, I've done this before myself, quite honestly. I've used a lot of hacking utilities that completely remote control a user's system, and you can see everything that's on their desktop. So it's quite frightening, really, and that's why we need to have these kinds of things like firewalls. So in a small business, for example, or even any business or a home, you'll have a firewall in most cases. This could be a hardware firewall or a software firewall. A software firewall would appear on a server, and then it runs as a service, and it constantly monitors attempts at inbound traffic. A hardware firewall will do the same thing, but it'll just be a different vendor. It'll be like Cisco, or it'll be something like Juniper Networks, or what's the other one? Checkpoint firewalls, that sort of thing. So especially on a corporate side, you're going to probably have solutions more like that. Many of them will also act as proxies, which will transmit in and out internet traffic on behalf of the clients that are back here. Anyway, I'm getting a little bit off topic there. But the main point of the firewall is to block ports that are not actually absolutely needed inside of the network here. And it separates the public internet from our private network. Now, some people think, oh, that's enough. I've got, even if you're in a home or small business environment, they might think, well, I've got one of those Linksys internet routers, and it's got a firewall built in, so we don't really need firewalls in here because we've got our Linksys internet router. That's not necessarily true, because these hosts here, if they're laptops, they could have been out where there was no firewall at a public airport or something. They could have gotten infected with the virus, brought it back into the environment, and then they subsequently infect everybody else, because a lot of those viruses, that's what they do. They spread around without any interaction on behalf of the users, on the user's part of this. So for that reason, we very often still need to have some kind of a rudimentary firewall, at least, on each one of these. Now, I've got to say, we've had a firewall since Windows XP that's built into the operating system. And Windows XP was okay. It was free, and if it was there, might as well use it if you don't have anything else that's more sophisticated. But I got to say that with Vista and Windows 7, it is actually a pretty good firewall, and I would recommend it even in a higher-end corporate environment. So let's take a look at some of the Windows Vista, Windows 7 firewall features. And I bring Vista into this because a lot of the features started off with Windows Vista as new features. First thing that they do is they'll block inbound and outbound traffic, whereas XP would only block inbound traffic. This is going to be true all the time unless there's an exception made. So, for example, if a user has somewhat unwisely decided to put a web page on their own personal Windows 7 computer, well, then they would have to open up port 80 in most cases so that people could access it through HTTP. So that's an exception that would have to have been created for that user's web page. There's also boot time filtering. You see, in the past, when a computer starts up, then there's a period of time between which the network card is initialized and the firewall loads, and that could be several seconds or even a minute or so, depending on how slow the computer is. And that's a potential window of vulnerability that, although small, could be exploited and has been exploited in the past, because during that time, there's no protection at all on that network interface, and an exploit only needs a few moments to be able to do its job. There's also network location awareness settings. And this is useful because in different network contexts, you'll have different firewall requirements. For example, if I'm in my own corporate network and I'm authenticated in the domain, then I'm in the domain network location awareness profile. As a result, I probably have more ports open or more firewall rules open so that various network services can probe my computer, and things such as communication with my email server or my proxy and all these other kinds of things will be opened up because I have a corporate context there where I need to contact other servers, and maybe they need to contact me as well. Another example of that would be maybe I've created a printer that's shared. Well, I want other people to use this printer in my little cubicle, and when I do that, then it opens up automatically the appropriate rules on the firewall for me in my domain profile. But when I'm out there on the Wi-Fi in the airport, I don't want those ports left open because those sharing ports are potentially vulnerable, by the way, and have been very often exploited in the past. So when I'm at the airport, I want a different set of rules to apply, and that's exactly what this is. It'll be aware of your network location awareness, and it will apply those settings. Now, a new feature with Windows 7 is that we'll also apply those network location awareness settings per interface. Let me show you an example of that. If you look here, you'll see that these two network interfaces, which are my actual literal Ethernet cards, they are connected to my domain here because they were able to contact the domain controller here. Therefore, I was automatically placed in the domain network. But down here you see a couple of other interfaces which are actually inconsequential. These are just VMware kind of virtual adapters that are used for virtualization. But it could have been something else. It could have been a dial-up modem connecting to another network or an internet connection. Or it could be one of those cellular wireless internet cards that could also be attached here. And when it's attached, I might want it to be on the public network. Well, if this were a Vista computer, then it would just take the combined total of all of these and apply the weakest security settings. That would be, or rather the most restrictive security settings. That would be the public network setting, even though these two network cards are on the domain network. Well, now with Windows 7, it will be able to apply distinctly between this network location awareness setting and this network location awareness setting. And starting with Windows 7, we also have something here called Full Stealth Mode. And what that does is it blocks operating system fingerprinting. You see, what happens is a lot of times a hacker knows that they can't directly attack your computer and get in immediately anyway, but they need to identify what operating system you're running, because then they can run down a checklist of various vulnerabilities against your operating system, which most of the time that's going to be Windows anyway. But you see, when they send a packet to you, they're waiting for some kind of response, and it might even be a NAC or a negative acknowledgement or just any packet. They don't even care if the packet somehow gives them permission of any kind. They're just looking for an answer, because each operating system manufacturer creates their packets slightly differently. So a negative acknowledgement from a Mac OS X might look different than from a Windows machine. In fact, a Windows 7 NAC might look different than a Windows XP NAC. So anyway, based upon the packet that they get back, they're able to identify what kind of an operating system that you're running, and then they can start to issue exploits against that operating system. Now, this is something that cannot be disabled, and that's good for a couple of reasons. Number one, we don't want somebody who's just kind of a casual browser looking at the firewall settings say, I don't understand that, so I'm just going to disable it. The other thing is, a lot of exploits will actually get in through some other avenue, and then even though they can't directly take over the computer or something like that, they might be able to stop a service or stop some kind of a security function, and then they will open up the way for other exploits. Well, since this can't be disabled, then that's going to be a little bit more difficult to work around. So how do you actually work with Windows Firewall? What interface are you going to use? Well, let's take a look at some of the interfaces that we have. And this is kind of confusing at times because it's not enough just to say, open up the Windows Firewall and make this change. Because there's about 5 different interfaces that you can work with, each of which serve a different purpose and have varying levels of capability. I think Microsoft did that on purpose, even though it's kind of confusing. But I think they did that because they want to, they kind of want to baffle the casual user who's not technical, but that is a local administrator, such as a home user. We don't want them getting into the firewall and just start turning things off that they don't really understand. So that's probably why this is, but one of the most fundamental interfaces you can use is simply the Windows Firewall and Control Panel. And with this one, you can only view the status, but not make any real changes to the Windows Firewall. And for that, let's go ahead and take a look at the Control Panel here. And then we can see here that under System and Security, we have Windows Firewall. All right. Now here is where we're just seeing information only. I can click all over the place here, and all I can really kind of do is collapse and expand this thing. That's pretty much all that I'm limited to. You can see here that I'm not connected to a home or work private network or public. I'm really only connected to the domain, and so that's the only one that shows me anything. But it does tell me that the firewall state is on, and it's going to block all connections to programs that are not on the list of allowed programs. This does not tell me what those allowed programs might be. I know that there's at least one. There's actually several. But it doesn't show you any of that kind of information. So this is kind of the consumer level look at the Windows Firewall. So if someone says, hey, is your firewall turned on? They can at least go here and say, it says I am. So they can at least do that much. However, there's another interface in the control panel that says you can customize settings. With this one, you're able to turn the firewall on or off. You're able to block various things, such as various applications. And you can also set it up so that a notification will appear anytime the firewall is blocking an application, and that would allow you then to open up the port as necessary to allow the traffic out. Now, this is when it's using outbound traffic. Again, this is how it's different in some ways than Windows XP. Because let's say, for example, that I'm trying to open up an FTP program like FileZilla, which is what I usually use. It's a pretty good little application, a freeware application out there. Well, of course, FTP uses TCP port 21. So the first time I might use that on a Windows 7 computer, if I use the default settings, it'll prompt me saying, FileZilla is trying to open up port 21. Do you want to allow this, yes or no? And words to that effect. So the way that would be set up is if I were to go into this and I were to change notification settings or turn the Windows Firewall on or off. These actually both go to the same place. It's more user-friendly to give you a couple of different options here. But look, change notification settings, takes me here. Okay, so if I go back, turn Windows Firewall on or off, takes me here. Now, it's kind of like this. If you can notice any difference between the two of these, then you need different antipsychotic medicine than what you're already taking, because they're the exact same interface. But you can see here that the domain network location settings, again, it turns on the firewall. I could turn that off. All right, that wouldn't be recommended, but I could. I could also block all incoming connections, including those on the list of allowed programs. Now, you don't want to do this very often, except that if you're concerned that you have a serious security vulnerability that might be attacking you right now. You might do that until you can track down what's causing the problem. You can also notify me when Windows blocks a firewall, blocks a new program. Okay, so these all pretty well explain themselves, and you can see that they're turned on for each one of these. Now, although they all look the same right here, in reality, they're going to be a little bit different in practice because they each have a different set of rules depending upon their network location awareness, as I mentioned earlier. Now, I also wanted to show you my own interface for my own workstation here, and that is that if you look at this, it looks like we should be in a real panic because we have no firewall settings whatsoever. Except that if you look at this notification, it's that the settings are being managed by Semantic Endpoint Protection, which has its own firewall application. Therefore, it's able to interoperate with Windows here in such a way that it will not constantly pop up the notification in the notification area telling me that I have some items that need attention, including the fact that I should turn on the firewall, because it recognizes that although Windows Firewall is not on, that's okay because I have this firewall. So a lot of times a third-party product will turn this all off in favor of its own firewall, and just be aware of the fact that you might be seeing that on some systems that have a third-party product. Now let's also take a look here at the Windows Firewall interfaces as we continue on, starting with the Windows Firewall with Advanced Security now, and this is where you're going to get quite a lot more detail. And this will give you very granular rules. You can configure a lot of different stuff, whether it's TCP or UDP, which port number it is that you want to allow or restrict, whether you want to allow a specific application to open a port. By the way, that's another feature that wasn't on my earlier list, but with Windows Vista and Windows 7, if there's a certain application that opens up ports and allows traffic to go out on those ports, when you close that application, guess what? Those ports close up as well. So that's kind of ingenious. But anyway, you can do all of that kind of stuff, including identifying authentication. Maybe I want to be able to communicate with my FTP server. But I want to first of all confirm that it really is my FTP server. Well, you can include authentication in this so that it has to authenticate itself to me and confirm that it really is the server that I think it is and not some imposter or man-in-the-middle attack. Another thing I like about WFAS is that you can take all of the settings that you've so carefully crafted and you can export all those settings so that you can then import them on a second, third, or any number of other machines. That way you don't have to recreate the wheel on those machines if they have the same or mostly the same settings. And if they're not all identical, of course, you can just make minor changes to the exceptions. You can use the UI, which is Windows Firewall with Advanced Security, or you can use the NetShell utility to be able to do that. Now, let's go ahead and take a look at an example as well. Oh, and I also want to show you there's a different interface as well that's not listed in this, so I guess there's actually 6 total different interfaces you can use to work with the firewall. But then we'll get to the WFAS here in just a moment. But first, let's go up here to, again, Control Panel, System and Security, Windows Firewall, and we've all been here before. And then this is another item that wasn't on any of the whiteboards, but it's Allow a Program or Feature through Windows Firewall. Notice that I can then change settings as an administrator, and then it opens up these other things so that if I wanted a home group, I could certainly select that option, for example. Or I could just pick from another program and say, hey, I've got FileZilla here, and I need to work with an FTP server. Well, I can then add that one, and it would also then open up any ports as necessary. But for the time being, I'll return here, and what I'm trying to get at for the time being is the advanced settings. Now, the reason why I want to go here is because I want to show you some of the different things you can do here. But first, I want to also identify that if I look at the inbound rules, then we can see that there's some things that are turned on and some things that are not. We don't really need to explore all of those right now, but I want to look at a specific item to point out how this is going to be automatic to a degree. That is these remote desktop items. Notice that you can set it up for the public profile or the domain and private profile. All right. Now, if I go back down here and I take a look at my system settings, let's go back here to System and Security and Remote Access. Notice that if I turn on certain features within Windows, it's going to automatically adjust those settings for me. So now when I click on Apply here, we're going to see Remote Desktop turn on when I refresh the screen by right-clicking up here and choosing Refresh. And then having done that, now notice, look down here at the bottom. It says Remote Desktop. I'll click off of it so you can see that it's green. Remote Desktop for the domain and private is now enabled. Notice that it did not enable it for the public connections. Why is that? Well, that's because at the time I enabled the rule, I was already connected to a private network. So it only changed it for the private settings. But if I want to manually enable it also for the public environment, I could do that by double-clicking there and choosing Enabled and clicking OK. And now we would see that it's enabled for both public and the domain and private. Now, it's probably not a good idea to leave it on for the public environment, so I'm going to go ahead and cancel that for the time being, or remove the enabled setting. All right, let's take a look at another thing here as well with WFAS, and that is how we can create our own set of rules. So, for example, you can see here that this desktop is actually a remote desktop connection that I'm connecting to remotely. All right, we'll talk more about remote desktop in I think it's our next nugget that's coming up after this one. But one thing that I want to be able to do sometimes is to be able to ping that computer. Before I try to make a remote desktop connection, I might just want to see if it's actually there, or if I forgot to turn it on, or something like that. So what I can do is to ping its IP address. Now this is in my actual desktop that I'm recording from, and I'm going to ping this machine and see if it gives me a reply back. So I'm pinging this machine in the background that we see here, and I'm not getting an answer back. Why is that? Well, I can see that it's already up and running, so obviously that's not the reason why I'm not getting a ping reply. The reason is because by default, ICMP protocol is blocked. ICMP is the Internet Control Messaging Protocol, and when you ping a host, it replies with an ICMP echo, which means that, yes, I heard you, and here's my confirmation of that, and that's how I get a reply back. Whereas if I were to ping something else that was available, like my router ping, then you can see I'm getting ICMP echo replies coming back to me. So what if I wanted to enable ping packets over there? Well, I could do that on this remote machine. And again, a remote desktop connected to this computer right here. And I'm going to try to enable it to reply with ICMP echoes. So I'm going to right click here and just choose New Rule, and then I'm going to choose a specific item, which is a custom rule. So let's click down here to custom, give myself a little bit more room, and click on Next. Okay? And then what I want to do is to apply this to any program that might want to use it, or I could also specify that this actually applies to a specific program. Now that would be highly uncommon for just ping packets, but for any other kind of a function, maybe another port that I was trying to open or something like that, maybe I'd have an application or some kind of a service that needed that particular port to be open. And you can see here that if I click Customize next to Services, that I could identify, a specific service in here and say that it applies only to SNMP traps or something like that. All right? But I'm going to leave this at all programs, which is suitable for our purposes. And then when it comes to the protocol type, of course, this is going to be an ICMP for IP version 4. And then all the rest of this is pre-built. Notice that I don't have the opportunity to select any of the rest of this, including the ports and so forth. And that's because it's a kind of a pre-packaged ICMP package of different settings. If you want to look at a little bit more of the settings, you can click on Customize, and you can see that this one applies to all ICMP messages, but there's actually a lot of different messages relating to ICMP. So, for example, one of the ones is that if you try to send a message through a router and the packet is too big for that router and it's not designed to handle the packets of that size, maybe because of framing and stuff like this, then it could send back a reply saying that the echo was too big. Okay, so those are some kinds of examples of that sort of thing, but I'm going to cancel that and just leave everything the way it is at the default for the time being. And then I can apply it to any IP address on the local IP address. And in this case, that's really only one. It's my 10.10.10.34 IP address. But if I had multiple network cards, and sometimes you'll have some network cards that have multiple IP addresses on them, then I could specify additional ones here as well. And then which remote IP addresses does this rule apply to? And for this one, I could say I want it to apply to any IP address, but if this were a laptop, for example, that would also apply if I were in a public Wi-Fi, and that might not be wise. So I could also specify only these IP addresses, click on Add, and I could say this IP address, and it might be a specific one, 10.10.10.20, for example, or I could do an entire range of addresses, 10.10.10.024. That would be anything on the 10.10.10. network using a Class C subnet mask, so that entire range. Or I could just specify a specific range of addresses, 10.10.10.1 through 10 or something like that. Okay, so there's several different ways that you can go about doing this. I can also use a predefined set of computers, such as my default gateway, and then you'll see some other servers here, like Win servers, DNS, DHCP, and so forth. That doesn't really apply to ICMP packets, but it might be useful for coming up with certain other kinds of rules if you wanted to make sure that you allowed a certain server to gain access. So in this case, this would allow access from any of the hosts in that entire network ID. Then what I want to do is to allow the connection. I can also choose Allow the connection if it is secure. Now I'm just going to stick with the top one. Obviously the bottom one explains itself. But for exploratory purposes, I'm going to briefly click on Customize here. And you're going to see that we can customize this according to several criteria. Now what do these settings mean? Well, you can allow the connection if it is authenticated. And this uses IPsec, which is well beyond our scope for the time being. But IPsec can authenticate both parties in a transaction using a number of criteria. One of the ones I like most in Active Directory domains is that it can use the Kerberos protocol, which is a pretty secure method for authenticating both user logons, computer logons, all sorts of things of this nature. So IPsec can use that. It can also use certificates or a pre-shared key, which is mostly just used for testing. But this would make sure that whoever is trying to ping this host is going to be authenticated and not some internet stranger, for example. It can also be integrity protected. This means that any of the messages that are sent are not going to be modified in transit. And if they are, then some of the hash algorithms that calculate all of this out will identify the difference and then reject that message. You can also require the connections to be encrypted here as well. And this is pretty much the same as selecting this item, but it adds encryption. Okay, so it's going to give you both encryption, integrity, and authentication. And you can also allow computers to dynamically negotiate encryption. This is useful if you have a number of different computers through several generations of Windows, or maybe, I don't know, Linux computers or whatever, and they may need to negotiate to see what level of common security ground they can reach between the two of them. And then you can also just use what we call null encapsulation. This is still some level of security. The packets still have to be, or the connection still has to be authenticated, but you don't have integrity, so the packets could be modified, and you don't have privacy, so there's not going to be any encryption of the packet payload. That could be important if you have passwords and things like this that are being transferred in the exchange. You can also override block rules. We don't have a lot of call for that, but if you had certain administrative tools that you needed to always be available, then you could select this option to enable those items. But for the time being, I'm going to go ahead and cancel this because we're not going to really use that one. We're just going to stick with the allow the connection, and then I'll just go ahead and click next. Here's where it's important to know that you can select which rule this applies to, or when this rule applies, and what network location awareness is important. I'm okay with it being in the domain and privately, not publicly when I'm in the coffee shop or whatever. Okay, so I'm going to go ahead and click on next here again, and I'm going to say this is my enable ICMP echo request. Okay, and that's pretty much it. Then I can specify down here, domain and private only or something like that. Now let's return to my main recording computer, and again, this window right here, the command prompt, is on the computer I'm actually recording with, and I'm trying to ping this one in the background with the Windows Firewall settings open. Okay, so I'm going to ping 10.10.10.34 where I've just configured that rule, and unless I mess something up, I should get a reply back. Ooh, there you go. Okay, I finally did something right here. So I configured that rule properly, and now we were able to get echo replies. Now, once you've created this rule, you can go back into it and double-click on it to customize some additional settings, whether you change your mind about something or whatever. For example, I'm allowing the connection, but if I wanted to secure it, I could choose that option here as well, which gives you the same options that we saw in the wizard just a moment ago. We can also go to Programs and Services, again specify a program associated with this or a service. Computers, we could say only allow connections from these computers. Now, of course, I get a message here that says I also have to allow only secure connections over on the General tab. That's where I have to authenticate the computers. So it's not really very useful to select this unless you also make sure that the computers are properly authenticated. So you can't just have someone who renames their computer to one that's supposedly allowed, for example. It has to go through an actual authentication process. But you can do the same thing for users and allow only authenticated users here as well. But again, we're going to go ahead and skip that for the time being because we didn't use that. Here again, we could change these items here as well as the interfaces. Now, we have these interface options. Local area network is the one that is going to be used in this case. But if I had additional local area network connections or a wireless card connection or something like this, then I could select those options as well, but we'll just choose all of those for the time being. And then here's something interesting for edge traversal. Now this relates to network address translation firewalls. And sometimes both of those things are the same device. So for example, again, if I go back to my diagram here, this could be a NAT device. What do I mean by that? Well, if I'm on the 10.10.10.0 network right here, then probably my interface on this network to the router that goes out to the internet is probably 10.10.10. I'll put .1. Okay, so that's my router's address is .1. And then over here on the public internet, I have to have something else because anything in the 10 dot range, remember, that's a private IP address range. Well, that doesn't work on the internet. So I need to have a public address. Let's just say, I don't know, 124.16.5.2, something like that. So this is a public routable on the internet address. And this is on another interface on my firewall device. And again, this could be a Cisco, a Checkpoint, who knows, whatever else it could be. Now, what I'm able to do here is when this client here wants to go to a website, okay, they want to access this web server out here, they can't use their private address. So they go through the firewall with their current address, which let's say that's .3, something like that. Then the firewall and the NAT device, if it has that capability built into it, will convert the request more or less from coming from 10.10.10.3 to looking like it comes from this address on the internet. So then it routes all through the internet till it gets to this web server. The web server returns it, and because of a table that's been built on the network address translation device here, it knows where to send the packets back to, and it knows that it originally came from this host. That's what network address translation does. Now, this does raise some concerns because we may not want this is called edge traversal, when we get packets back through this direction to the NAT device back on into our private network. That's edge traversal. If you don't want that kind of a thing to happen, maybe you have some security concerns with that, you could block edge traversal. But notice here that if we block edge traversal, that relates to unsolicited inbound packets. So that's not where I was trying to get to a web page. That's where just somebody out here on the internet, or some virus or whatever, is just trying to, squeak on through the firewall and hit me directly. Well, we might not want that, so we can block that, obviously. But the other things I could do there is I could just go ahead and allow edge traversal. That might be useful if I have a specific purpose here. For example, if whatever rule I'm configuring is for a service that I want people to be able to access. Maybe they're running an application on this that's designed for public use. Maybe it's demonstrating one of our software products or something. Well, I would want to allow that in unsolicited. I could also defer to user or to an application, and then it will prompt either one of those as necessary. And then continuing on here, we have the scope, where we can specify, again, any range of addresses or whatever, and then the protocols or ports. And again, if you don't set up a pre-configured protocol type here, then you can customize that to anything else that you want. And I'm not going to click OK past this, but I'm just going to say, what if we wanted this to be a TCP item instead? Well, then we could specify, well, I only want that to work on port, let's say we have a specific application on port 777, okay? And so that's our local port, and the remote port that we want to receive this from would be maybe the host that's running the application remotely that's trying to access my computer. Maybe they start off running on port 888. So this would just be an example of how that could work here as well. And that's most of the same settings that you see in the wizard, with some exceptions. There's a couple of additional options there that you can select. Now, similar to an inbound rule, you can also create an outbound rule using mostly the same method, just new rule, and takes you through the same kind of wizard. There's really nothing else different about this, except that the traffic is flowing the opposite direction. Also, if we go back up here, let me crack this open again. Remember these settings right here for the security settings? Well, we can configure the authentication that takes place in this. For example, there's nowhere in here that says whether to use Kerberos, whether to use some kind of certificate, a pre-shared key. How do I know what kind of authentication method they're using? Well, you don't until you configure that. So what we would do is to go to Connection Security Rules. We'd right-click here to choose a new rule, and then we would specify what kind that we wanted. For example, with isolation, I would restrict the connection, as you can see here, based on authentication criteria, such as domain membership or health status. What's health status? This relates to network access protection, or NAP, and that's beyond our scope here as well. But that can make sure that the computer has properly got its virus updates and Windows updates and the like. There's also authentication exemptions, so that we could not authenticate connections from the specified computers. This might be the case if we have maybe a standalone machine of some type out there that we know needs to contact this computer, but it does not have the conventional authentication mechanisms like Kerberos. It wouldn't use that if it's not part of the domain or not part of a Kerberos realm, for example. So we might need to make an exception for that kind of a computer. And that, by the way, is an exam objective, is to know about this. We can also specify a server-to-server authentication, a tunnel, which is between gateway computers, source to destination, and then custom. And I'm just going to quickly go to custom because with the custom one, you could manually create any one of these creations, these rules. So I'm going to click on custom here to show you the various components that are involved in it. So what are the computers in endpoint 1? Well, again, any IP addresses or specific ones, and again, you can choose a range and so forth. Okay, same kind of thing that we saw earlier, as well as the other endpoint. Okay, so you can use either end of that to custom configure that part of it. You can also request authentication for inbound and outbound. You can, and a request, by the way, is just a request. If the destination host does not respond to that request, then you can just go ahead and use the connection anyway, but it will be unauthenticated. Okay, here it would, by hard and fast, require authentication for inbound connections, but it would only request authentication for outbound connections. That's generally a good balance for security in many cases. But if you really want to play the lockdown game here, then you would require authentication for in and out. Okay, so that might be another option that you would select. And here's what I was talking about earlier. We could say for the computer and user, use Kerberos 5. This is actually a very good mechanism, very good security mechanism. A friend of mine has shown me, a hacker friend of mine has shown me a little utility that actually does crack this. But it is something that is not bulletproof, but it is relatively secure anyway, even though there is an exploit out there for it. Plus, if I'm being technical, the crack isn't directly against Kerberos 5. It's a crack against some of the mathematics that are involved that kind of accompany Kerberos 5. Anyway, splitting hairs. So you can see that some of the other options here as well, and we could choose advanced, and this is where we could choose additional authentication methods. For example, if we were in an environment that didn't use Kerberos, we could click on Add, and maybe we're using older Microsoft methods. We could use NT-LAN Manager and stuff like this. Yeah, so those are some of the, forgot to actually select something. Some of the different methods that you could choose. Again, choose a specific type of a protocol that you might be interested in. I'll just leave it as any for right now. And then again, you specify where you want this to apply, and then it's pretty much next, and then you name it, and then you're finished. So this relates all again to the security rules that we see in this connection security rules node. Now let's also return to the top node here, right here where it says Windows Firewall with Advanced Security. Let's right-click on that, and notice here that this is where I could export and or import policy. I can also restore the default policy. This is very useful if you've been experimenting, maybe in a lab or something like that, and you came up with a whole bunch of rules and you kind of lost track of what was blocked and what was allowed, and it gets to be kind of a tangled mess. Also, you can diagnose and repair, and it kind of searches through to look for any kind of conflicts or problems that it might have. But I really want to go to the properties here, which is where we're headed in this instance. Here I want to just point out that you look at the various tabs, domain, private, and public profile. This will identify whether the firewall is on, or whether it's blocking inbound connections or allowing them. And you can see the self-explanatory options for each one of these. And again, we can also protect specific network connections, but I've only got the one for the time being. And then we also see the various settings that we can come up with here as well. For example, if we want to see a notification when the firewall tries to block a program, okay? Do we want to allow a unicast response to multicast or broadcast network traffic? So if this computer is the source and it's sending out multicast or broadcast traffic, if we choose yes here, which is the default, then what happens is it'll wait 4 seconds for a reply, and if it doesn't receive anything, then it'll kind of shut down the invitation more or less. It won't allow a unicast back to this client. And the reason for that is because if this is a known system that does multicasting, then I don't want someone to indefinitely be able to send packets back to it. All right, I want to say yes to lock them down to 4 seconds. Otherwise, if I choose no, then they cannot send back a unicast response at all of any kind. Okay, so that's what the difference is there. In a while, we're going to talk about group policy. Group policy has a very similar interface to this whole thing we've been looking at here. But what I can do with this is to merge the rules, because I might have local firewall rules, and I might have local connection security rules. And if I say yes here, then what's going to happen here is that we'll merge the settings locally with the settings in the group policy. If I were to choose no, or to clear that setting, then what would happen is administrators could still create rules back here, but they'll pretty much be ineffective. It'd mostly just be academic in that kind of a context. So those are some of the kind of settings that we can work with here. And then, of course, you can also log, and that might be useful if you want to see when someone is trying to invade this computer on a specific port, or if they keep trying to access this computer on a specific port. Also, for the authentication and encryption settings, you can use IPsec. These are where you would configure IPsec, which is well beyond our scope right here again. But once again, this can be configured based on certificates. It can be configured based on Kerberos and the like. Let's also address a couple of other tools you can use for the firewall interfaces. One of those would be NetShell. This is going to be a little bit more complicated because you don't have a UI with it, and sometimes you just have to look up in the command line help or something like that the various switches you would need. But we've used NetShell in the past as well, and you can see that this is going to be useful with something like Windows Remote Shell, which we'll start to address in our next nugget as well when we talk about remotely administering Windows. And you can also use NetShell again in scripts. So for example, maybe I have a set of standalone workgroup computers that are not part of my domain, so I'm not able to use group policy objects to configure their firewall settings, because you'll see here shortly that we can do that. Well, what I might want to do is just put a script together and have each one of them execute a script that might add 15 or 20 different rules, rather than me having to sit down at the keyboard and bash out all of the commands myself manually. And as an example of that, I'm going to use NetShell Advanced Firewall, and then add rule name equals, and then I can call it whatever I want. In this case, I'm going to block FTP that's outbound, so direction is out, and then we point to the FTP program here, but you can point to whatever program you want, and then my action here is going to be to block that traffic, and we can see now that it's blocked. And if I want to change that back to allow instead, well, I can do that as well. Okay, so that's one way that you can work with the firewall, again, is through the NetShell command. Now, let's return to this common interface that we saw with Windows Firewall and Advanced Security by using a group policy object. With this, we get the same interface with the Windows Firewall with Advanced Security, so it's going to look familiar, except that it doesn't show anything when you first see it. There's no rules that are already configured there because the group policy objects are pretty much set at not configured for virtually everything. And what you have to do is you have to go in there and configure them for what you want. This is very useful for a larger scope, so that if I have computers that are part of the domain, maybe I could set up a set of firewall rules for all of my my Exchange servers. And I could put all of those Exchange servers in a single group policy object, in a single OU, link a group policy object to that OU, and then whatever rules I set would apply to all of them in just a few minutes. Now for group policy objects, this is going to expand our scope significantly. So for example, here you can see I've opened up a group policy, and what I would do is I would just link this to the domain or a specific OU as necessary. And anything that's in that domain or OU, if I link it to an OU, will be the recipient of the policy settings that I configure here. So by configuring one set of rules here, I could apply that to dozens, hundreds, thousands of computers all at once if I want. Much simpler than going to each one individually and fiddling around with those settings that I just showed you. Now, what I could do with this, for example, is to make sure that the firewall states are configured or not configured, for example. So I could go to the Windows Firewall properties, and I could say anytime we're in the domain, I want the firewall on. And I want inbound connections allowed, outbound connections blocked, whatever. You can just configure this to whatever your security settings are, and all the rest of this is the same. You can do the same for the private, you can do the same for the public, and obviously for public I would definitely turn on the firewall. This might be useful, for example, for my laptop users. And then for their inbound connections, I would definitely block those. And then outbound connections, I might need to allow those, depending on maybe they're trying to make outbound connections to a company internet web server or something like that, or they're trying to make an outbound connection to an FTP server and download files from us or something like that. But you get the idea there. We can configure all of those settings and then forcibly pretty much enable the firewall. That would prevent anybody that's a local administrator on their own computers from disabling the firewall, because every time they do that, they don't get to go to the cute little websites that launch viruses on their computer and stuff like that. So anyway, we could override all of those settings here, and then we can configure our own inbound or outbound rules. Notice again, there's nothing here because there's a lot of pre-built ones that are already there on local machines, but here I could just click New Rule, and then there's some predefined ones that I can still work with. So for example, if I had a organizational unit full of file servers, I might click File and Printer Sharing and link this group policy object along with these rules to the OU that has all of my file servers. Okay, so I'd click on Next, and then I would allow these things in. By the way, notice that one of the settings here is Echo Request. If you see that that's ICMP here, anytime you enable file sharing, file and printer sharing on a host, even if it's just a Windows 7 machine, it also turns on ICMP. So you might not have to build that ping issue separately. Okay? And then you can again allow the connection or specify security if you want for it as well. And then I'm just going to cancel that for the time being. But then once I had configured this and it has been properly linked to an OU or the domain, it will then apply the next time those destination clients refresh their group policy. In this nugget, we took a look at Windows Firewall. This is where we looked at the firewall's functional overview, first of all, to get an idea for what firewalls are supposed to do. Not just Windows firewalls, but any kind of a firewall, really. Then we looked at the firewall features that are available to us, and although we don't identify all of them, because there's quite a few, we really identify the ones that are particular to Windows Vista and Windows 7, especially as compared to the older Windows XP. We take a look at the firewall interfaces. There's actually a total of 6 different interfaces that you can use. So it's a little bit confusing at times, and you got to really think through sometimes, okay, which interface do I want to use if I got to do this task? But pretty much you can do anything if you are up to working with the Windows Firewall with advanced security. That's the highest level of interaction that you can have with the firewall rules. You can also apply the rules using a similar interface, using a group policy object, except that, of course, the GPO will apply to a whole bunch of computers at once because it's going to be able to be linked to the domain or organizational unit. Well, I hope this has been informative for you, and I'd like to thank you for viewing.